All right. Good afternoon, everyone. So officially, let me welcome us to today's bootcamp, day 2 of our virtual bootcamp. I want to believe most of us were around yesterday. So, but for those that were not around, let me just introduce myself. My name is Ian Fatoba, and I'm going to be your host for today. And yeah, so I'm not going to talk as much as I did yesterday because, of course, that was an introductory, speech. So for today, I believe that we all have, the background we need already from what I said and from, the class from Mr. Gbenga yesterday. So I won't take that. So today we're just going to, get right into it, a recap, and then, go right into today's session. So thank you for joining us. Thank you for taking this opportunity. Like, it's one of the very rare opportunities out there. And I'm not just talking about this introductory class. I'm also talking about, our advanced class that is coming up in March 1st, as a matter of fact, and, talking about all the opportunities embedded in that course, the richness of the curriculum, the affordability of the course, and the flexibility of the payments. Like, it's something you won't uh, really get out there. And, and this is what we've done. This is what we've been doing for years, trying to, bridge that gap between the demand and the supply rate in the tech market, and not just in Nigeria, also globally. So if you have chosen to really take this path, I want to say congratulations to you. And like I said yesterday, I want to believe a lot of things have been demystified already, and you already know that you are cut out for this, and you are the most perfect person for this career path, right? So yeah, thanks for joining. I can see a few people. I can see Shegun Bolariwa. I can see Mr. Olashupo. I can see Joshua, Isaiah, Toby, Tulualashe. So thank you all for joining. With me here is Gbenga Shodunke. Of course, I know we had the moment yesterday, and I want to be sure we're really blown away. I was the fact that I'm working with, and every time he talks about coding and programming, it blows my mind, right? So yeah, I won't believe we had a day yesterday, and today promises to be even better because it's going to even go a bit deeper into the things you need to know, away from the introduction and the background he gave yesterday, and more into, all right, what do you need, when do you need it, how do you determine if this is what you need it, and how do you even determine your focus. For some people, coding is not new, but they just need to know where to start from, what to focus on, and where to really push and channel their energy. So all of those things will be answered today. So please do not forget, if you have anything to say at all, any comments, maybe while he's talking, just drop a chat, right? And it's possible that he says something and then you don't understand, you want a clarification. Instead of unmuting your mic and disrupting, you can just drop it. I'll pick it from the chat box and then I'll send it to him so that I can, work on it. So please kindly mute your mics, and if we have to talk, we will have a session for that. So yes, welcome once again, Yanu again. And right now I would like to call our CTO and the founder of Zelnus Technologies, that Mr. Gbenga Shodunke, for to just get back to it, and let's start. Mr. Gbenga, are you there?
Yes, I have.
All right, you're welcome.
Thank you so much, Yana. And
Yeah.
I welcome everyone. Good evening from Nigeria here. Good evening, everyone. I hope we are having a great day. And it's so nice to have you all in class today. I can see so many people are still trying to connect. Some are coming off and dropping. So I hope they will meet us on the way early enough. And also, I know not everybody here was able to make it yesterday. So I would like to find out, before I go on, if you are new to this class today, could you just unmute and signify if you didn't join the class yesterday? Hello? I hope you can all hear me.
I didn't join.
Okay, who's that?
Yeah, we can hear you. I
Sorry,
didn't join.
what's your name, please?
Isaiah.
Yo. Okay, Isaiah Tosin. Okay,
This Isaiah.
Isaiah Tosin. Okay, okay. Nice to have you in the training today. And I know some of you missed the notification in your email, and some were busy. But not to worry. Is there another person that missed the class yesterday? Okay, for now, let's assume it's only Isaiah Tosin. And but don't worry. We have a recording of the class. It's currently being uploaded to our YouTube channel. So after today's training, it's going to be sorry, uploaded. Both yesterday's class and today's class will be uploaded to our YouTube channel. So you can always go back to listen to it. But it's going to be there for only 1 week. So after a week, it's going to be taken off the public, the public view. Okay, so we expect everyone to go back and refresh, watch within 1 week, so that we can catch up with. But I'm still going to be doing like a summary. Okay, I'll be doing a recap of yesterday's class. It's going to be very very brief, fast. So I'm just going to be breezing through it. And so those who are not around yesterday can just pick up the recording of yesterday and and catch up. Okay. So I welcome everyone once again. And the recap is going to be highly interactive. I mean, it's going to be another opportunity. I mean, for me to get a feedback, to be sure we all understood what was, taught yesterday. So within this 4:15, within 5 minutes, I would like someone to give us a power summary of what was taught yesterday. I mean, if you want to recap to Tosin, you want to explain to Tosin that wasn't here yesterday, about what was taught in classes yesterday. So let's see who can give that a try. Let's see if you can make Tosin understand what was taught yesterday. So who wants to go? I'm waiting. Should I call a name? I'll just call somebody. Okay.
Okay, let me try.
Okay, thank you so much. Go ahead.
Good afternoon, everyone. Yesterday yesterday was the beginning of the class, and one of the major things we talked about was is coding difficult, which we ended up defining as individual base. To some it might look difficult, and to some other it might look simple. And from there we talk about computer system. We look at the two branches of computer system: the hardware and the software. The hardware being the parts that can be seen and touched, and the software being the other part that cannot be seen. And then we also talk about the categories of software, being the system software, and then the application software. And during the class, we are also asked to define what a software is, which we are given the definition that a software is a set of instructions that can be stored and run on a hardware. A set of instructions that interacts with the hardware. Then we started identifying some devices like the input and output devices. The output devices, when we talk about the display unit, the monitor, and other things. We also talk about the input devices like the keyboard, the mouse, so on and so forth. From my end, I think these are just the basic things we talk about. And before, lest I forget, we also talk about opportunities, the various opportunities that is open for software developers, out there. So these are just a few things that I can highlight for now.
Wow, awesome, awesome. Thank you very much, Joshua, for that recap. Anybody else wants to try? We have like 2 to 3 minutes more, to do this. So I'm going to be calling someone. I'm going to be calling Prof to give us a recap. So I know it's going to, I expect it to be very, very powerful being a professor. So, Prof, do you want to help us out? And I mean, help those who couldn't make it yesterday. Hello? Hello, is Prof there? Okay, I think I'm just going to be calling on somebody else. Let me see. Okay, I can see Toluwalashe Sanyaolu. Do you want to help out those who didn't make it yesterday and give them a very concise summary? Are you on the call? Are you there? Please unmute your mic. Hello, Toluwalashe Sanyaolu. Are you there? Wow. Hello, I need to know you're even following. Okay, can anybody hear me? Just to be sure.
We can hear you. It's possible his network is bad.
Okay.
Or I can hear
Okay.
you from my end.
Okay.
And I'm sure you understand.
Can every other person hear me? Just to be sure.
Yes, I can hear you, sir, from my end.
Okay, thank you. Toluwalashe is not responding, and probably the person is running from giving us the summary. Who else can I call here? Let me call. Let me call. Since nobody wants to volunteer, Olaniwaju Adelaja. You're welcome. Could you give us a summary of yesterday's class to help those who couldn't make it yesterday?
Okay, so briefly, I myself, I logged in early, but for some reason, I didn't know how I got disconnected. And I was thinking it was still before. So I just joined in like 2 minutes when you were calling to Lualashe.
Oh, okay. Yeah. I saw I just came in. So we've not actually started today's class. We're actually trying to have a recap, of yesterday's class.
Okay.
So
quite a number of people.
Quite a number of people are here now that couldn't make it yesterday. So we're trying to help them out. So I need someone who can, try and give them a summary of what was launched yesterday. Okay, someone is raising up his hand. Adamu Abubakar. Okay.
Okay.
Do you want to answer the question?
You mean me or Adamu?
No, Adamu. Okay, Adamu, hold on. Let Larry give us the recap. Then I'll call you afterwards. Okay, you can go ahead, Larry.
Okay, I'll just give you a show that I may not go sequentially, but I think I can try.
Yeah.
So it started by introduction of the Zionel Academy itself, yourself, and I've forgotten the lady who introduced herself first. Then went on to Ian. Then went on to you, starting off the class, telling us about what programming is and how easy actually it is. Talked about the industry, the debts, that's the scarcity of programmers and people who can code, and how it is a highly sought after skill. Talked about how there are opportunities, even home and abroad, the flexibility around it, and the lucrativity of the job, of being able to do the such job itself. Then went on to bringing us into understanding that programming is very easy. It is nothing superficial as we may have learned from other times. And you put a lot of examples around it, a lot of explanations. It was really a thorough class. and it really puts my heart, I can say, and I think a few other people also spoke, put our hearts to rest as to understanding that there is really nothing to it. It is not anything big. Then started with introduction, talked about computer, talked about software types, talked about hardware, software, talked about input devices, output devices, basic computer knowledge, and then you talked about how that we can we don't have one of the vital things that you mentioned that was key, which I still remembered very well, is that don't try and use the approach with which you learned in the university in Nigerian system to approach programming or coding. That don't try and be a crammer. Try to get what is being said, understand it, internalize it, because that's what you'll be doing as a programmer. You'll be solving problems. So you understand the problem. And just like when you read and you can see it back in your own words, it shows you've understood it. The same thing is the kind of mindset we should push to getting at, and that there are things called syntaxes, which are like alphabets of each program set, whatever program it is, and that even in any programming language you're going to. Okay, I think it's trying to reconnect.
Okay, hello everyone.
Yeah, I'm done, sir. I think at the point where I finished was when your network got.
Yes, so sorry everyone. I just had to connect to the backup internet right now. You know, as usual, but I hope it's not going to be a reoccurring. So I'm back. Thank you very much for that powerful recap, Mr. Larry, and hope you can all hear me now. Hello, can you all hear me?
Yes, I can hear you. At least I can hear you.
Yeah, can you see my slide?
Yeah, yeah.
So that we won't, you know, miss the slides like we did yesterday. What can you see on the slide now? What can you see?
What's your name? Zionel Academy.
Oh, okay. So let me reconnect. Let me reshare. Okay, so what can you see on the screen now?
Still just your name.
Are you sure you are? Can anybody see my screen? Can anybody see my slide? Please, feedback. Can anybody see my
Not
slide?
yet. Not yet.
Okay. Okay. Sorry, hold on. Let me try and share from. Okay. What about now?
Yes, we can see your face.
My slide now.
I think so. I think it's loading.
Okay.
Okay, says your bandwidth is low. I guess maybe that's why we can't see it.
No, it's actually back. I'm back on the fast internet.
Okay.
You can
now.
see it now.
Okay, you can see it now, right? So what can you see on my slide? What page can you see?
Software.
Oh, okay, perfect. So I think
Software.
okay, we're good to go now. So thank you very much for your patience. We'll just hit the ground running. We have more people here today. And like I announced earlier, in case you missed yesterday's class, a link will be sent to you via email of the recording, yesterday's recording, and today's recording will be sent to you via email. So you can always go back, to pick up what you missed yesterday. So thank you for the powerful recap, Larry and Joshua. So we won't spend too much time today. I'll just, go straight into today's topic. So yesterday we we start looking at the two main categories of a computer. Two main categories of a computer. We started looking at this yesterday, and we said a computer can be categorized into the hardware and software. Now, for the benefit of those who are just joining us today, the reason why we have to come this low, because some of you might be thinking this is supposed to be an introduction to coding course, okay, and you are probably expecting, us to dive in straight into the coding and start writing, the codes and the syntaxes, just to put guide your expectations, aright. Like I said yesterday, software development is much more than coding. Okay, writing codes, like I usually say, you don't solve a problem with codes, or codes don't actually solve a problem. Okay, now first of all, the purpose of a software developer or a programmer or a coder, whichever one you use, you can actually use them interchangeably. So the purpose of a programmer, or one of the main objectives of a programmer, is actually to solve problems. Okay. Now, softwares are actually used to solve problems. Problems for organizations, problems for human beings generally. It's basically meant to make manual processes, automated or faster and efficient. Okay. So, what a computer can do, a computer actually, one of the qualities or features of a computer is the ability to multitask and the ability to do, several things and complex things. Computers actually have the capability to carry out complex operations, okay? Though human beings have a larger capacity to store a lot of things and to even to process certain things, that computers can't or won't be able to process. Okay. However, in terms of calculations and complex tasks, the computer is much more powerful. Okay. So, but a computer is not powerful on its own. The computer is not powerful by itself. The computer is powerful because human beings are responsible for actually instructing the computer on what to do, telling the computer what to do. So, and we said yesterday that software is a set of instruction that is written and run on the computer to do specific tasks. Now, those who write the instructions are actually called the programmers, okay, which is what you're aspiring to be. So the reason why you're in this class is actually to learn how to communicate with the computer, or how to write, languages that the computer can understand. Okay, so so I was saying that I can't remember what I was saying that brought me here, but let me just go on with the class. So so you might be thinking, yeah, I remember now. So you might be thinking, why are we, coming down to what is a computer and all that and all that. So the point I was trying to establish is that coding or writing code by itself is not actually the solution to a problem, but the programmer who is writing the code is actually responsible for, bringing or coming up with a solution in the first place. Okay, so there's this maxim that is usually used in the programming world that, you think twice and you code once, okay, which is to let you know that before you start coding, it is necessary for you to think first. What are you thinking of? You think through a solution. Okay, so I was saying, as a programmer, you're a problem solver. So you are actually writing codes so that the computer can understand how to solve certain problems. So a computer cannot actually solve problems on its own, except someone makes it solve the problem. So as a programmer, you're responsible for first thinking out the solution. So after thinking out the solution, you can now write the set of instructions, okay, for a computer to carry it out. Okay, so now, one of the main objectives of this course is actually to show you the general overview of the software, of the software world, of the software industry, and to let you know how it works, to let you know all the parts. And I was saying yesterday that the software world is like a large forest, with many trees, okay? And I mean, with so many unclear parts. Okay, one of the reasons why it's difficult to learn coding or programming by yourself is because there are so many information, so many parts to take. Okay, so which makes it difficult to actually know the right part to take or the right combination, okay, of things to put together to actually come up with a solution. You understand? So learning how to write the syntax in itself, is not the first thing, one should jump into. But in understanding, some basic principles of coding, understanding even, the psychology of learning coding, like we mentioned yesterday, a lot of people already have a blocked mind towards learning coding. So because of that, they are hindered even from learning it. So some of the things we touched yesterday, when you go through the video, the recording yesterday, there were actually keys to help you overcome those challenges so that by the time you are done, your mind will be set to actually learn it. So for the benefit of those who are just joining, just know once again that coding is not difficult. There's nothing difficult about coding, okay, because you have a guide. Okay, we are here to guide you to learning it, okay, and it's going to be much more easier for you. So this particular course is very, very, very important, and it actually makes the difference between those who successfully learn coding and those who will not. Okay, I can tell you 100% that many of the people, in fact, most of the people who have taken this course have successfully sorry, I'm back, and hope you can hear me. Hope you can all hear me. Hello, I need to confirm if you can hear me.
Yeah, I can hear you.
And
Yes,
you can
yes,
see
we can hear you.
my screen as well.
I can hear you.
Can you see my screen?
We can't see your screen again. No,
Okay, I guess it's still loading.
it's not showing at the moment. Okay, it's not showing.
Okay, I just wait a bit for that to come up. So, sorry, give me some seconds. Um, Hold on, please. Okay, can you see my screen now?
Yes.
Yes.
Oh, beautiful. So we're on a faster network now.
Yes, we can see.
So
Yeah.
that's the battle we're fighting. We have all sorts of internet here, and hopefully this will work to the end of the class. It won't break anymore. So let's just go ahead. Yeah. So what was I saying? Where did I stop? Can somebody remind me? Hello? Hello? What was the last thing you had? So I can know where to start from. What was the last thing you had? Can somebody else help me with that?
I think you can continue with there needs to be the computer can solve the problem by itself.
Oh, okay.
Someone has to.
Okay. Thank you. So software generally. So I was saying that. Sorry. Okay, someone just sent in a message trying to join. I think the person is joining on another meeting. Hold on, please. Let me try and resolve. Okay, I think we're fine. So, So we're just going to be starting from, from what is the software. So we looked at the two categories of hardware, the input devices and the output devices. Then we went on to what is the software. Yeah. Then we mentioned that the software is a set of instructions written that can be stored and run by the hardware. So I think this was what we stopped yesterday, the categories of the software. Okay, the system software and the application software. Then we also looked at what a system software is. It's also called the operating system. Then we saw the different types of operating systems: Windows operating system, Mac OS, or Apple iOS, then Linux, then Android. Okay, so most of us know Android as a mobile, operating system. Yeah, that's correct. It's actually a mobile operating system. It only works on mobile phones. Okay. And we also see the types of application software. We said that application software is software that give functionality to a computer. So, and that was where actually we stopped yesterday, the application software. So today we are going to be starting the class from the categories of application software. Can you see my screen?
Yes.
Okay, thank you. So these are the 5 categories of application software we have actually. The desktop applications, we have the web applications, we have the hybrid applications, we have the mobile applications, and we have the games. Okay? So the desktop application. Now this class is going to be a bit interactive. I'm going to be needing feedback and I might be calling names, okay? Because there will be a bit of game here. Now, one of the things we're going to be doing today is we're going to be busting a lot of myths. Okay. Now, from experience, whenever I'm taking this particular section of the course, okay, from here going forward, there are a lot of myths around some of these things. A lot of us know some things, or a lot of us know some things wrongly. Okay, our definitions, we have wrong definitions about some of these things, that we are determined to bust, at this point in time. So we are not going to be living or coming out of this course still holding those myths. Okay, and some of such myths is by the time we get to networking, the internet, I'm going to be asking you questions, okay, and you're going to be giving definitions, and I'm going to be proving to you that your definition is, or what you understand by that particular thing is wrong. Okay, then I'll be showing you what the real definition is all about. Okay, so one of the things I want to mention now is desktop applications. Okay, so desktop applications are actually applications that run on a computer. Okay, there's something I don't want to use a particular word because I'm going to be asking the question, and if I mention it, it's going to give out the answer. So, firstly, can somebody tell me what a desktop application is? What you understand by a desktop application? That's number one, and why such applications are called desktop applications. Okay, I want to know where the name was derived from. Okay, so who wants to go first? What is a desktop application, and where was the name derived from? So who wants to try? I mean, we all know desktop applications, I assume, but in case you don't know what a desktop application is, you're going to be learning about it. And don't forget, this is like a refresher course. At least we expect you to have taken the computer class, even in secondary school, in primary school, at least in secondary school. And there are certain things we expect you to still remember. Okay, so that's why I think I have the right to ask you such questions because I expect you to know it. Okay, so we also have computer science students in our midst, who might want to help out, so that the class can be faster. So what is a desktop application and how was the name derived? Who wants to go first? Or who wants to help us out? So I'm going to be calling on Tenny, okay, Sonia, to help us out. What is a desktop application?
Yeah, good afternoon.
Good afternoon.
I'm not really sure, but I think they're like built-in applications.
Hey, built-in applications. What do you mean by built-in applications?
like they, how do I put it? They like run with the computer, like they don't need any other, like they don't need an external source or something like that. I'm not quite sure.
Okay, nice try. Who else wants to try? Where's the computer science students? The two computer science students of yesterday, are you here? Please come out and show us your power. Actually, this class, I expect this is actually the strength. Yesterday, it seemed as if I was bashing the computer science students yesterday, but actually, the computer science course is a very powerful course. It's a very interesting course, and there is actually a lot about computer science. Though computer science, like I said yesterday, doesn't actually necessarily focus on software development as most people would think. Computer science actually deals more with the hardware part and the electrical part, okay, of the computer. Although there's no way you can talk about the computer that you won't talk about the software part. So that is the reason why most computer science, courses actually also delve into the software programming, okay? But computer science is actually much more broader than programming and all that. There's the hardware part, there's the electrical part, there is the, there's the networking part and so many other parts of computer science, okay? So these other parts are also very, very, very important. And even for a software developer, they are also important. Just understanding the knowledge, you might not be able to, or you might not be required to actually apply the knowledge, like that every time. Okay, but just knowing it, there's a way to prepare your mind, to actually know some deeper things when you go higher or when you get to a high place in your career. Okay, so this is just to say that computer science is actually also very, very useful and important, to learning coding, but not directly, Okay, so Tolu Ibrahim, do you want to help us out? What is the desktop application? Hello, Tolu, are you there?
Hello.
Yeah,
Okay, thank you. Yeah, you want to help us? What's the desktop application?
there are applications that run on the system mainly. Everything needed to run the application is present on the system.
So that's similar to what Tennis said. So you are going with Tennis definition, right? Okay.
Yes.
Okay. So
Hello.
Okay. Yeah. I can hear you,
Hello.
Samuel. Yeah, I can hear you. Go ahead, please.
Like the way the word desktop.
Yeah.
Yeah, desktop doesn't require any other like other needed devices like maybe the website or all those kind of things. The desktop is just something locally. So I mean those applications that they can use without making use of the web, something like that. Locally that can run maybe on the desktop or laptop.
Awesome. Thank you, Samuel, for that, wonderful definition. Actually, that is very, very correct. Very, very correct. So the applications that don't require the web to run, okay, they are also called standalone applications. Okay, they run on their own. They are installed, independently. Okay, they are installed on the computer, independently. All right. So now, every application you see on your computer, okay, whether they came with the computer or not, okay, they are called desktop applications. Okay, so that's why I agree in a way with the first two definitions. Okay, but the only thing is that they don't necessarily all come with the computer. What happens is that computer manufacturers preload their computers with certain desktop applications. Just the same way when you buy a new phone, the phone doesn't come blank. It comes preloaded with certain, mobile apps. Okay, so the same way that some computers come with certain desktop applications preloaded. Okay, so and but that doesn't mean that you can't install other desktop applications into the computer. So Basically, they are standalone applications that are installed on the computer and they don't communicate with other applications on the computer. Okay, so now the other part of the question is the name. Where was the name derived from? Desktop applications. Samuel, do you want to answer that? How did the name come about? Desktop applications.
The desktop, I think desktop is most people. Desktop doesn't require I don't know, web doesn't require web, but I don't know how the name came about.
So when you say desktop doesn't require web, what do you mean by desktop? Now, what are you referring to the as the desktop?
No, let me say there's a difference between the desktop and the laptop. I don't know. I think the desktop doesn't have battery that can last compared to the laptops. I don't.
So I think I've been able to achieve my aim. I just wanted to bring this out. Okay. I know a lot of us also have this sense of definition of desktop. Okay. But actually that is not correct. Though, like we mentioned yesterday when I was showing you about the hardware devices, the examples of hardware devices, I mentioned the case, and I think Anne, asked the question that are we referring to the case of that other big computer, the one that is placed on the floor, which is called the desktop, or are we referring to the screen? And I said we're referring to the case of the desktop. So that big computer, that big rectangular box most of the time, and sometimes they are usually flat, placed on the table, is called desktop. Okay. Now, and like you said, there's also what we call the laptop. Okay. So whether the laptop or the desktop, they are all called PCs, personal computers. Okay, PCs, personal computers. Okay. Now, so of course, we all know what a laptop is. It's mobile. You carry it on your lap, or you can carry it anywhere, place it on the table. And the desktop computer, the bigger ones that are not as mobile. Now, that name was not derived from the desktop computer, actually. Okay. Now, there's something else that's called the desktop on your computer. Okay. Actually, every computer has an area called the desktop area. Okay. Hold on. Let me try and share my screen again. Hold on, please. So I'm sharing my screen now. Can you all see my screen right now? What can you see now?
That's the desktop you can see.
Oh, so why did you call this the desktop now? It's like a light was just turned on inside of you, right?
Yes, that's the desktop.
Okay. So what you're seeing right now is actually the desktop. Okay. I know many of you might not know it is called the desktop. This is called the desktop area of the computer, actually. And those icons you are seeing on the desktop, okay, are actually called desktop applications. Okay, so the reason why they are called desktop applications is because they reside on this area called the desktop area of the computer. Okay, so that's one of the myths that we've been able to bust today. So desktop applications are not called so because they run or they work on the computer. After all, this is a laptop, and yet we have desktop applications on them. Okay, so they're called desktop applications.
Are you talking about the default?
The default
Hello,
what?
sir.
Yeah, I can hear you. Go ahead.
Are you talking about the default? Because some of you said they are needed on the desktop. Those applications are needed on the desktop, and now you're showing us your desktop. But then I'm sure some things were moved from one folder inside that's not on the desktop. If this background, given your definition, that this background is a desktop, and then they need to be. What about if I import a folder or an application and then just paste it there? Does that make it a desktop application?
Yes. Now, I'm talking about
That
the
means
origin.
any application can.
Yeah. So it's not about the
Sorry, I didn't get that.
yeah, so it's not about whether you can move the application, into a folder or not. So I'm trying to talk about where the name originated from. Okay, so originally, those that gave it that name, desktop applications, actually probably because they lack name, they were looking for the best name to call such applications, just to differentiate it from other types of applications. Okay, so they probably came up with probably the earlier versions of Windows. Okay, of course, we know the Windows is actually the first operating system that came up with a graphical user interface. Now, we'll be coming to that very fast. That's actually the next thing I'll be talking about. So let me just go ahead and talk about it now. So the Windows application, which was developed by Microsoft, was actually the first graphical user interface operating system. Now, what that means is that, the earlier versions of operating system that existed were in a form called DOS, disk operating systems. Now, those operating systems don't have user interface like this, where you can create folders and delete folders and open files. Now, the first set of operating systems are in this mode. Can you say black screen right now?
Yes.
Okay. So the first set of operating systems, that were created by Microsoft and so many other operating system manufacturers then didn't have any user interface, didn't have a place where you could click. It only had a black screen like this, okay, where you could type in codes, okay. So if you want to open a file on your computer, you have to open it with a code, okay. If you want to create a file, you have to open it with the code. If you want to delete a file, all those things you do today just by clicking on the mouse, and you're able to get a lot of things done fast. That was not so, okay, in the early days of the operating system, development, all right? So, but later on, Microsoft, Bill Gates and his friend, Paul Allen, were actually the first people to come up with the innovation of making computers user-friendly, okay, by developing something like this, okay, that uses a mouse to click and open, create folders, and manipulate files. Okay, so at that point in time, of course, there was nothing called icons then in a DOS operating system environment. Okay, so now with the new graphical user interface, there are icons that are clickable, that you could click and open and to do whatever you want to do on the computer. So at that point, they must have been confused. What are we going to name this kind of applications that work on the computer? So, and of course, a lot of new definitions must have come up at that time. At that time, they decided to, the decision to name this, this area, the desktop area, must have come up, and that must have necessitated the reason why applications that work as a standalone, applications on a computer are called desktop applications. Okay, so that is the origin of the name. So I realized while teaching, taking this course, a lot of people don't actually know, why it is called desktop application. I think somebody actually asked the question a long time while I was taking this course, and since then I decided to start asking people, why that name was being called that. So it's not because they run on a desktop, okay, but because primarily then when you install an application on a computer, they appear on this desktop area as a shortcut, as you can see. But that is not to say that you can't copy them and you can't replicate them in other areas, like inside the folder somewhere in the document. Okay, so you can actually do that, but primarily they are installed, or they are stored as a shortcut on the desktop area. So that must have been why they called it. That was actually why they called it desktop applications. Okay, so is that fine? I think we can move on now, right? So I'm going to go back to sharing the slide again. So can you see my slide again now?
is yours your sister?
So can you see my slide? Can I go ahead with the slide?
So
my cousins did it themselves, like from the beginning to the end. They didn't even need
Hello? Can you hear me? Can somebody hear me?
Yes, we can hear you.
Okay, can you see my slide?
Yes.
Okay. All right, I'm trying to bring this up on my computer so I can go ahead.
She's gonna pay a lot of money. And she can do it
So
herself.
somebody's mic is unmuted.
Step by step. Then also asking whether I'm not interested.
Okay, I think I'm just going to mute it for me. Okay, so sorry, hold on a second. I'm trying to bring up the slide. It's just hanging somewhere on the. Okay, it's back. Okay, so you can see my slide desktop applications, right? So
Yes, we can.
now, one thing about desktop applications is that they can only be installed on a single computer to perform a specific task. Okay, so if you need to play music on your application or on your computer, you need a desktop application or a music player desktop application. Okay, and if you need to type in a document, you need a Word document or any other document application. Now, this doesn't have to do with a particular operating system. Okay, all operating systems have this feature. Okay, so be it a Windows operating system, okay, developed by Microsoft, or a Mac OS or Apple iOS application, okay, sorry, a Mac OS or Apple iOS operating system, or a Linux operating system, okay, they all have what we call desktop applications, okay? So, and they all have the same features. They can only be installed on a single computer to perform a specific task. Now, quickly, let's look at the disadvantages of desktop applications. One, they are difficult to maintain. Okay, they cannot be shared among multiple computers over a network. It has to be installed on each computer. So what that means is that if you have an application, let's say a Microsoft Word application, which is also a desktop application, okay? You have it on a system that you used to type, okay? So if you have another laptop, okay, and you also like to type on that other laptop or on that other computer, you can't easily share the same software you are using on your first computer on the second one. No, you have to actually install a new, a new copy of that desktop application on your new computer. Okay. So what that means is that, let's say in a school, university, okay, or maybe in a school library or in a university library, maybe that has up to like 100 computers. Okay. So if you want to have a desktop application like Microsoft Word, so that students can type text and create a document, that means you have to install a Microsoft Word desktop application 100 times, okay? 100 times, that's one time each on each computer, on each of the 100 computers. So now expand that. If you have up to like 500 or 1,000 computers, it means you have to install them one by one. So you can already imagine how hectic that would be. So that's one of the major disadvantages of desktop applications, okay? Now, the other disadvantage is that they are uneasy to use, okay? So they are confined to a physical location and hence have usability constraints, okay? Then the third thing is that they are not easy to distribute. I mean, this is similar to what I said earlier. You can't easily distribute desktop applications. Once you have it, most of the time, it is tied to a single computer. Okay. So although recently there are desktop applications that have multi-user licenses, okay, which means you can use one software on multiple computers. You understand? So I mean, unlimited number of computers, maybe like 4 users, 5 users, or 10 users. Okay. So they are very, very limited. But the major disadvantage, which I want to point out, is that they are not easy, to install. They're not easy to spread or to distribute. You understand? So that brings us to the next kind of application or the next type of application software called web applications. Okay? So web applications are applications that run over a network. They are most commonly accessed via a web browser like Google Chrome, Firefox, and Opera Mini. Okay, so that's one major difference between web applications and desktop applications. Web applications actually, run within a browser. They are applications that are accessible via a browser. Now, another thing to note in this definition is that they run over a network. Okay, so briefly, although there's a separate topic which we'll be going into very soon, that treats networking. Okay, networking is a very, very crucial aspect of computers and of software development, such that if you don't know it, and I can tell you today, I've met so many programmers, most of them don't even know about networking. Okay, they don't know about networking, and that makes them actually limited, that makes them shallow. Okay, so when it comes to, now let me just deviate a bit. One thing you are going to have to know how to do very well as a programmer is the ability, like I said, while you are trying to solve problem as a programmer, you will encounter other problems. So while you are developing problems, you will encounter certain problems that will not make your software work. Okay, so one of the things you have to learn to do very well is the ability to discover solutions to problems while you are writing your codes. Okay, now when you are writing a code or when you are developing a software, most of the time your software will not work the way you intend it to work. Okay, and these problems that hinder your software or your code from working the way you expect are called bugs. Okay, maybe you must have heard of it before. So that's the technical name. Okay, you call things within your code that are not making your code work the way you expect. They're called bugs. Okay, so one of the things that make it easy for you to discover bugs, okay, is your understanding of your understanding of the programming language, number one, your understanding of programming generally. Then another thing is your understanding of the infrastructure on which your code is running on. Now, remember we said yesterday that a software cannot run without the hardware. Okay, and we also said that the hardware is actually nothing without the software. The hardware is lifeless without the software. So both of them actually are interdependent on each other. Okay, so for you to be, when you're developing a software, your software must run first on a computer. So which is one of the reasons why we have to look into what is a computer, look at the peripherals, and to know the internet, so you can at least know some basic things about the place where your software is going to be running. You understand? Okay. So now another place where your software, that is, if or when you are developing web applications, is that you have to understand the ecosystem on which web applications run, which is on a computer network. You understand? So if you call yourself a software developer or a programmer, you're developing softwares that are meant to run on a network, and you don't have a deep understanding about networking, okay, at least to some extent, not too deeply, but at least some basic understanding of computer networking, then there's no way you will do well, because by the time you develop the software and you throw the software into a computer to run, and the computer is plugged into a network, and you find out that your computer is running alone, and your software is running alone on the computer, but the moment you plug in the computer into a network, it stops working. Okay, so to troubleshoot such kind of problems and to be able to eventually fix such kind of problems, at times might require you to understand networking, might require you to understand how networks work and even how the internet works. So that's why most of the topics in this course, though they are not actually directly coding, they don't have to do with writing code, but they have to do with where your software is going to be running. So that, which is why it is very, very, very important. Okay. So going back, let's get back into the course. So one key thing I want you to pick from this definition of web application is that, one, they run over a network. You must remember this, because we're going to be, dwelling here in subsequent sections. Okay, so one, they run over a network. Then two, they can only be accessed via a web or via web browsers. Okay, so now let me just briefly define what a network is, a computer network is. Okay, a computer network is actually the connection of two or more computers. Okay, it's a connection of two or more computers. So let me stop here because the next session I'm going to be going in depth into networking. So web applications actually can run on a computer independently. Okay, but you will not actually feel the power, or you won't be able to tap into the advantages of a web application if you run them on a single computer. Okay, you will feel the advantage more when you run them in a network environment or where computers are connected to one another. That's when you will actually feel the impact more. You understand? So now examples of web applications are online shopping cart of an e-commerce website. Okay, computer-based test web applications for writing online exams, or any application at all you need a web browser to access. Okay, so basically any application you access via a web browser, be it a website, okay, and be it any other web application that you access via a browser, they are called web applications. Okay, so, and one major advantage of web applications over desktop applications is that web applications are not limited to a single computer. So now the example I gave earlier in the case of desktop application, that if you want to install a software on 100 computers, with a desktop application, you have to run them one by one on each computer, okay, like 100 times. But for web applications, it is not so. You only need to install a web application once on one computer. Then every other computer on a network, okay, can access the web application without having to install it on those other computers. So that's one of the major power of web applications. They leverage on the benefits and on the power of networking, okay, to be able to easily distribute web applications. You understand? So that's a very, very, very important point to note about web application. So now the next kind of application software we're going to be looking at is, or are called hybrid applications. Hybrid. Okay. So hybrid applications are a combination of both desktop and web applications. Now at this point, I would like to ask, can you see my slides? Because I've been moving from one slide to another slide. Can you see I'm on the hybrid application page now? Just a quick feedback. Can you
I
see?
can see it.
Okay, good. So hybrid applications are a combination of both desktop and web applications. So what makes them like desktop applications is that they have to be installed on a single computer. Okay. However, like web applications, they can run on a network and can be used by multiple users on a network. Now, an example of this, or examples of this are Skype, Slack, WhatsApp, for desktop, and even Zoom. This Zoom we're using now is actually an example of an hybrid application. Okay, so if you notice, everyone now, before you could connect to this call, you all had to download Zoom either on your phones or on your computer, correct? Okay, before you could connect to this training. Okay, so that is exactly what makes it a desktop. I mean, what makes it like a desktop application. Okay, so if we have 100 people who want to join this training, each of them have to download a copy of Zoom application. Okay, but what makes them similar to web application is the fact that they can run on a network. So even though you all have to download a copy of Zoom application on your computer or on your mobile phones, okay, you see that we all could connect. So right now, my computer is connected to your own computer or to your own mobile application. So we are all connected right now. There's a networking effect right now. I can talk to each and every one of you, and each and every one of you can talk to every one of us, or to every other person. Okay, so that networking effect, is what makes it similar to web applications. So Those are the things, those are part of the benefits, okay, you enjoy when you use a web application. Okay, but desktop applications, one of the greatest limitations is that it doesn't run on a network, which means a desktop application that is installed on a computer only stays on that computer. It cannot communicate with any other desktop application on another computer. No, it can't. It is only limited and restricted to that computer. Okay, but an hybrid application, though, has to be installed as a standalone application on the computer, but it can communicate with other desktop applications or other hybrid applications, okay, on other people's computers. Okay, so that makes hybrid application very, very powerful. So Skype as well is an example, because everyone has to download Skype. Every Skype user has to download Skype on their computer or their mobile phones, but then they all can connect to one another over the network. Okay, so that's a very good example of hybrid application. Now, the next type of application are called mobile applications. Okay, so mobile applications are applications that run on mobile phone operating systems. Okay, they are hybrid in nature. So mobile applications are actually hybrid applications. The reason why I brought, I brought it out is the fact that they only run on mobile phones. Okay, but actually they are hybrid in nature, in the sense that every mobile application have to be installed or downloaded first on the mobile phone on which they are to be used. Okay, but then those mobile applications have the capacity to communicate, okay, with other instances or other copies of the application on other people's phones. Okay, so that makes them hybrid in nature. So every phone you see on your mobile phone they are all called mobile applications, like Facebook, WhatsApp, or every other app that runs on your mobile phone. Okay, so going back, so now let's make an appraisal. Let me go back to the types of applications we have. We have desktop applications, web applications, hybrid applications, mobile applications, and games. So these are all the 5 types of application softwares you will ever have to develop. Okay, they are no more than this. So as a programmer or as a software developer, as an aspiring software developer, these are the different categories of software or application softwares you have to develop. Okay, but before we move forward, we will have to make a decision on whether you want to specialize in one. Now, it's very obvious that these are very broad categories. Now, it's very obvious that you might not be able, in case somebody is asking now, can I develop all kinds of, or all categories of application softwares? Okay, the answer to that is going to be very, very difficult well, not let me say it's going to be difficult, it's actually possible. Okay, a software developer should be able or might be able to develop across all these categories of application softwares. Okay, but there's a saying that when you try to chase 2 rabbits at the same time, there's a possibility that you won't catch any. Okay, so it's always a good idea that even if you want to do many things at once, you start with one. Okay, you start with one, you master that one very well, and after mastering it, you can move to another one. After mastering the other one, you can move to another one. Okay, so that is to say, at this point or after this course, by the time you've started the training proper, you need to make a decision, okay, on which type of application will I, or which of the category of this application do I want to begin with? Do I want to begin developing a desktop application, a web application, or hybrid or mobile games? So quickly, we're going to be doing a quick appraisal of each of these categories and see logically, okay, which one will be more suitable, looking at the pros and the cons and every other thing. Okay, so but before we even get to which application software am I going to be interested in starting with, let's go back to the system software. Now, don't forget, this is software, and we said there are 2 categories of software. We said there are system softwares and application softwares. So yesterday we looked extensively at system softwares, okay? And now, before we even say, let's consider application software, because I've not even concluded. So let us look at it together. Looking at system softwares or operating systems and how they work. As a software developer, do you think, it's a good idea, to learn how to develop an operating system? Do you think it's a good idea? Or if you have to choose between where to specialize, if you have to choose between specializing in operating system development and application software development. So based on what I taught you yesterday and what you have learned today about application software, which do you think is most reasonable to specialize in? So I need I really need as many people as possible to contribute this time around. Do you think it will be easier to develop software or operating system software,
Yeah,
or it will
I
be
think
easier to develop application softwares? Okay, go ahead, please.
yeah, I think developing an OS takes a lot much more. So I think for someone probably just starting out, I think it's better to just focus on applications for now.
Okay.
So that's my view. Maybe as we won't get more advanced or something, then you might want to now probably delve into some, OS side of things. So, but for now, I think
Okay.
the application is fine.
Thank you very much for your contribution. Does anybody have something contrary, to what Olashuk Oladipo just said now? Do you have anything contrary? Do you think actually we can give it a shot? What's in system, operating system development? Without the operating system, a computer cannot run. Okay, so why? An operating system is, if it's that important, so why not learn how to do it? Does anybody share that? That sentiment, or do you think?
Okay, for me, somewhere I feel operating system is like having a platform already where other things can be built on. And I feel somewhere the world is actually content with Windows, Mac, Android. Right now, Mac is on. You hardly hear even the one Nokia was using Windows. It's not so mobile phone friendly. Even I think there are lots of limitations compared to the Android. So I feel a platform has been built enough, or we have enough. But right now, okay, for even our workspaces and in offices, is Windows that's used mostly. And so and given from what you even said, a lot of funding, and I don't even want to talk about the work that has to go into it's almost like it's a company on its own.
Yeah.
Windows, we know Mac, we know Android, as in those are names already. Yeah. So I think that's been available. The younger ones can just build on what should be on the on these platforms. So it's easier. It's would I say more realistic? I don't want to sound lazy, but it's not as tedious as operating system. So I think I still go with what you said.
Oh, thank you very much for this submission. I don't think anybody would dare, say anything contrary to what both of you have said. Given the strong points you've put forward, I think it actually makes sense, I think I can assume that we all agree with what both of them have said, So, but just to add to what both of them have said, I think I also agree, because come to think of it, like, Anne said, we already have established platforms, we already have established operating systems. But let's assume somebody here, has a very deep mind and likes complex things. You wouldn't mind, what are they saying? Come on. I like complex things. Let me just go to the place where those difficult things are being done, Okay, let's journey with you. Let's look at it very well. So let's say eventually, let's even look at what it takes, to develop an operating system. Now, firstly, don't forget what we said about operating system yesterday, that it actually gives functionality. It makes the computer hardware functional. Okay, that is all the hardware, the hard disk, the mouse, the motherboard, and everything. They are all connected to the operating system. Okay, so that means that an operating system developer must understand, number one, the electronics of the computer. Okay, and frankly, that is actually what the computer science course, is supposed to prepare students, to be able to do. Okay, I don't know about Nigerian universities, but I know universities abroad, they delve so much into all those things, hardware programming. Even if they have to do any programming at all. They have to learn the hardware programming. Then they have to learn the electronics. How communication, takes place between all the hardware components. How the hard disk communicates with the, with the mouse input. How input and output, how they communicate, with one another, with each other. They have to actually understand that. So by the time you've understood that, then you now have to learn the programming language to now develop, or to write the code that will directly instruct the hardware directly. You understand? So now, for you to be able to even be an operating system developer, normally, except you're a genius, you're a super genius somewhere, normally you must take a course in computer science first, spend 4 or 5 years in a very good university, okay? Most preferably abroad, to understand all those things very, very well. Okay. Then after you've done that, you probably might even need to take masters in computer science to learn the advanced and probably specialize in the operating system aspect, of the computer. Okay. After spending many, many years, let's say you've now spent maybe close to 5, 6, 7 years to acquire this knowledge, and you now decide to, okay, start developing operating system. Now, let's look at this operating system industry, a little bit. Okay. Now, like Hans said, we already have established operating system Windows. I was saying earlier that Microsoft was the first, company to come up with a GUI, that is an operating system that has a graphical user interface. Okay, that makes people control files and open files with a mouse without having to type in codes. And since they came out with that, since they were able to break through, into that invention, they've been dominating the operating system industry, because it took a long while before another operating system, could be developed to have a graphical user interface. So that was actually the thing that makes Windows operating system dominate the operating system industry right now. Okay. So now, Oga developer, do you want to compete with Microsoft? Maybe you develop your own operating system and release it to the market and start marketing it, start convincing people, don't use Windows anymore, use my own operating system. Who knows you? Where? In Nigeria? Even if you're in the
The
US.
market is shut down against you already.
Exactly. You understand? So, and even Linux that has been trying for many, many, many years, to compete with operating system. Linux is actually an open source operating system. Okay, and open source softwares. At this point, let me use the opportunity to tell you what open source is. Open source softwares are softwares that are not owned by a particular person. Okay, they are open free licenses. So there are softwares that are developed by usually it starts with either an individual or a company or a group of people. Okay, and they now decided to make the code public. Okay, they publish the code publicly, and give it out to other people to use the code, not only to use the code, but to also, improve on the code. So eventually, what they do is that they organize a system around, how other people or other programmers are going to be able to develop the software. You understand? To improve on it and to make it better. Okay, and anybody can use it. You don't have to pay for it. It's free, and nobody will sue you for using the code. Okay, in fact, you can add to it and improve it. So that was, in the early days, open source started becoming popular in the, late 80s, early 90s, and some of these open source or some of these believers in open source ideology actually started it because they wanted to fight, private licenses. Companies like Microsoft, who have been dominating, the industry and making a lot of money, and they believe that has killed competition. Okay, so other products have not been given the opportunity to come up, so they decided to say, okay, let's develop it. Let's all come together. Anybody all over the world can contribute to this, and we can use it. So Linux has really, really tried with all its open, source capability and benefit. It has not been able to compete with Windows operating system because of the power of monopoly. There's something called the principle of forced entry. Okay, the first to enter the market actually has the opportunity to dominate or monopolize. Okay, so but Microsoft is only dominating in the area of client computers. Now we're going to be looking at that when we start talking about networking. Okay? So client computers are just, everyday user computer, like your computer, my computer, that we use, personal computers that users use, okay, to connect to the internet or to do other things, okay? So, but we have what's called server computers, okay? Server computers are computers that actually serve other client computers, okay? We're going to be looking at that too very soon. So they share resources. It is on server computers, you keep resources you want to share with other client computers within a network, okay? So Linux is actually dominating the server computer space more. Why? Because server is lighter, though it's not as beautiful as Windows operating system, because Windows has to do a lot in order to appeal to users, okay? But Linux is not actually targeted towards end users. It's targeted towards server, users or server providers. Okay, so that makes it very fast, and it also makes use of terminal. That's the command line interface that I showed you earlier. You understand? So that was what Linux was able to do in order to get their own share of the market. Okay, so now if you now say you want to learn how to develop operating system, Windows or Microsoft is dominating the client computer market. Linux is dominating the server, computer market, and it's even free. Okay, how will you compete with all these people? And somebody might be asking, so Mac operating system, Apple, they came up with their own operating system. So how are they surviving? How is Mac OS surviving? How come they became a third force and they came in and they started competing in the market? Now, actually, Mac is not competing with Windows. They don't even have the power, the muscle. Neither are they competing with Linux. Okay? Mac or Apple, is actually more of a hardware manufacturer. Okay? What Apple is selling more, they are selling their hardware. Okay? So that's why Mac is not interested in selling their software, that their operating system outside of their hardware. Okay? So what they did, is called, they did what is called product differentiation. In economics, it's what some businesses do in order to differentiate their product from other products in the market. So what happened was that Apple came in late into the computer manufacturing or the hardware market. Okay, so before then we've always had IBM, we've had HP, we have Lenovo, we have Acer, we have a lot of computer manufacturers already dominating the industry, competitively. Okay. So these other computer manufacturers, they have to rely on Windows, okay? If that for their client computers, since Windows is dominating, so they have to rely on Windows. So they go to Microsoft, they buy bulk licenses for Microsoft, and they install into their hardware, okay? Then they sell to people. So whether you are using HP or Dell or Lenovo, you are all using the same operating system, okay? So now, Microsoft, on the other hand, their business model did not consider using or developing or manufacturing hardware. They majorly stayed with operating system development for years, until recently when they started creating Microsoft Surface, which is more like a tab, it's not like a regular computer. Microsoft Surface that runs on Windows operating system and all that. So their focus was really not to compete with HP, IBM, and Dell. Okay, so now Apple, realizing that they are already a late entrant into both the software industry and the operating system industry and the hardware manufacturing industry, they, Steve Jobs started to think, okay, what can I do to gain an edge, in these industries? I can't compete with Microsoft because they are too big, or Linux, and I can't compete. I mean, I can easily compete in the hardware manufacturing space with HP, Dell, Acer, and other hardware manufacturers. Okay, I can compete with them, but what can I do, okay, to differentiate my product from HP, Dell, Lenovo, and all that? Then they came up with the idea of, okay, let's develop our own operating system, okay, so that once we develop our hardware, we'll make it very, very, very strong. It's going to be very durable. The screen will be different. It's going to be a very high spec. We're not going to be developing for the mass markets, for the everyday market. We'll develop for some special kind of people who appreciate quality, who have taste, who have class, you understand? So they defend to differentiate, their product in that aspect. So now, after developing a strong hardware product, we will now develop our own operating system. Though not to compete with Microsoft or Windows or Linux, but to be able to use it to sell our hardware that will differentiate us from other operating or other hardware manufacturers. And that was actually what brought them out, and they became very, very big, and they created a niche for themselves actually. And that made them very, 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 very big, and they hit the market, So I'm sorry if I had to say this long story, not to discourage you, but just to let you see that, it's actually, not, at least for now, it's not going to be an easy task to say you want to develop, operating system softwares. Okay. Now, I want to believe we all agree with everything that's been said. I mean, I just added my own point to what the two other people have said, saying that it's not going to be logical to begin your career, in software development, in operating system, software development. So if we have agreed on that, in case you don't agree, you can send me a message later and tell me why you don't agree. So, but in case we are all on the same page now, so let's now look at the application software. Now we have agreed that the application software is the most logical and reasonable area to specialize in. Okay. Now we've already identified 5 different types or categories of application software that you can ever develop. So the same thing we did, comparing the operating system software to application software. The same elimination method, let's try and see if we can apply it here as well. Okay, because it's good to start from 1 or 2, or 2 related, or 1. Then from there you cannot move on. You can now move on to other types of application software development. So from what we've learned about desktop applications, web applications, hybrid applications, mobile applications, and games, which of these do you think will be, logical and worthwhile to begin your career with? Who wants to also contribute now? I want other people to contribute to.
I think I'll prefer the web application.
The web application. Why?
I think these are like in an internet age, and we see most people like to make use of the internet to do so many things. So I think there are more problems need to be solved based on that web application more than the other sites. But if not that, I would say, okay, let's say go for the hybrid because it's a combination of both of them.
Okay.
Yes.
Nice point. Anybody else, has something else to say about that? Anybody else wants to contribute regarding this? Okay, in the absence of none, I think I agree with you. Looking at it, we've already seen the disadvantages of desktop applications. It's limited. Most organizations don't, they require an application that's flexible, that is easy to share. Okay, because most organizations operate within a network environment. So shortly we'll be looking at the benefits and advantages of computer networking. Okay, so that will help us better appreciate, the power of web applications. Okay, so desktop applications, you can't imagine banks, for example, a bank using desktop application. Okay, that's will not make them easily communicate. So most banks, most organizations use web applications, except for some special organizations that are in a certain kind of industry. Maybe the entertainment industry, for example. Okay, maybe video producers. Okay, or maybe animators or movie producers. Okay, the software they use to edit movies, or to produce new movies after they've shot their movies are desktop applications. Okay, because so these are specialized kind of applications. So such industries, yes, they actually need desktop applications. Okay, but now how many organizations? Well, this thing is all about opportunity. We're looking at where the opportunity abounds more. Okay, so well, another business case might be to go to an industry where the competition is not much. Okay, because it is highly complex. For example, to develop a desktop application to edit a software or to edit movies. Okay, it is actually very, very, very complex. Okay, but not too complex like that. But depending on, in this category of application software, actually you can decide to go anywhere depending on your direction, depending on your objective. Okay, but considering the financial or how lucrative, okay, a particular category of this application software is, okay, if I'm going to go by how lucrative, I think web applications will be better because they are in a much higher demand. Most applications use web applications, you understand? Then another thing I would like to point out is that the technology that is required, or the programming languages and the frameworks that are required to develop web applications can also be used to develop hybrid applications. Okay, and recently some of them now can also be used to develop even mobile applications. Okay, even games, depending on the kind of game you want to develop. Okay, because there are different kind of games. If you want to develop desktop games, then you need the kind of programming language and application that can be used to develop desktop applications to develop games. You understand? So looking at all this, web application is the best decision you can make to be a web application developer. So most of you must have been seeing a lot of things. Maybe you've been seeing maybe vacancies. We're looking for web developers of 12 years of experience. Now you have a better understanding of what that means now. Okay, so they are very specific. We're not looking for desktop application developers. So if you have the ability or the skill to develop desktop application, you can't apply for such jobs because they've said specifically we're looking for web developers or web application developers. Okay, so and most of the time they will also require the person to be able to develop mobile applications. Okay, usually web and mobile, you understand? So because they have the understanding that if you can develop web application, you should also be able to develop mobile applications. Okay, so in terms of commerce, in terms of for commercial purposes or for commercial considerations, it is better, more lucrative, to specialize in web application. Okay, so which is the reason why we brought out this tool. If you can still see my screen, advising or encouraging that web application development is best to start with. Then later on, we can now move on to mobile. Then later on, we can move on to desktop if you still want. For example, currently, in our company, we are working on a desktop application. Okay, and in how many years we've never had the reason to develop desktop applications. Okay, most of the projects we've worked on, most of the projects we are working on, about 80 or 9, I can say 95% have always been web applications. Okay, so clients or customers don't request don't usually request for desktop application. Okay, but this time around, because we have a particular project we want to work on that requires us to build desktop applications. Okay, so for the first time in a long while, okay, we are now building a desktop application. Okay, so what that means is that or what I will communicate with regards to that is that the same technology or programming language we are using to develop web application is almost the same we are now using to develop desktop applications, because some of these things have evolved. They've all entered one another now. So people are also thinking, people are developing, that's developers of programming languages and frameworks. They've been thinking of the best way to bring all these things together so that someone will not have to learn something entirely different. If you want to cross from one category, of application software to another, you understand? So that is the reason why it's actually seamless now. When you start with web, you can move to other areas, as fast as you can. Okay. So because of this decision now, we are going to be narrowing down into web applications. Okay. We're going to be narrowing down into web applications. So now I need a feedback here. So let me just quickly ask questions here. Who can remind me of what a web application is? From what we've learned so far today. I want somebody who has not spoken today. Who's okay? Kinsley, do you want to tell us what a web application is? Just to get a feedback that you're following me. Are you there? Okay, so who else wants to try? Who wants to try? So thank God, do you want to try? What is a web application? Hello, can you hear me? Can somebody hear me?
I can hear you.
Okay. Please remind us of what a web application is. Hello? What's happening now? Nobody wants to answer.
Hello, web applications are applications. Okay.
Yeah, go ahead. Go ahead. Hello? Okay, so we're going to be running now.
Web applications are applications that are run on the web. Yeah, they need the service of the internet to run.
No. That word is very, 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 very. Web applications don't need the service of the internet. They don't necessarily need the service of the internet.
The applications that run on a web server and can be accessed to a web browser, to the internet.
Okay, thank you for that. But that's the first part of the definition. There's another part I'm looking for. Something related to what the other person said earlier, that the applications are run on the internet. I want a correction to that. I want someone to correct that. It is correct, but it is partially correct. Okay, it is partially correct.
They run on a network. They run on a network.
Okay, thank you.
They run on a network.
Yes, correct. They run on a network. Now, saying the applications that run on the internet could be misleading. Okay, although the internet is an example of a network. Okay, so that's why I said it is correct, but it is partially correct, because web applications don't actually need the internet to run. Okay, so which means a web application can run on a computer that is not connected to the internet, or that is not even connected. In fact, the truth of the matter is that a web application primarily does not require a network to run. Okay, although they run on a network, they can run on a network, but they don't require a network to run. So meaning a web application can be installed on a computer that is not connected to the internet, okay, or not connected to a network, a local area network. A web application can run on a computer as a standalone, but it has to be run on the browser, okay? It has to be run on the browser. So we're going to be seeing that too as we move forward. So now who wants to tell me, people usually ask this question at this stage. Since nobody has asked me, I'm going to be asking you. Who wants to tell me the difference between a website, or is there a difference between a website or a web application? Have you ever thought of that before? Who has ever thought of that? Is there a difference between a website and a web app or a web application? Is there a difference? Do you think there's a difference? If you think there's a difference, what is the difference between the two? So this is why I will need the computer science student or other people, to tell me if you think there's a difference between the two. Okay, go ahead. Who wants to answer? Tony Ibrahim, can you try? Hello? Hello?
I think a website, the end user interacting with the website cannot manipulate any data on the website. He can just read and interact. But I think a web app, you can manipulate data, maybe inputs to.
Okay. Nice one. Nice try. Who else wants to try? Who wants to try?
I might not be right anyway, but I think for web applications, you don't necessarily need an internet. But then for network applications, you have to be connected to internet to use it.
No, that's so the question is the difference between websites and web apps. Websites and web apps. Okay, so let's move forward. That's a very nice try. Anyway, it's a very nice try. So, moving to the next slide. Hope you can all still see my slide.
Yeah.
Okay.
Hello.
So
yeah, can I try the difference?
Okay.
I think.
Yeah.
Hello.
I can hear you. Go ahead.
Can you hear me?
Yeah, go ahead.
Okay. I think the difference between the two of them is a web app is a software, and while a website is not necessarily a software. You understand? They are just web pages. You understand? Built to be hosted on a server. You understand? I think
that's a website, right?
Yes, a website is built to be hosted on server. Like
okay.
a web, they are all different web pages.
You
understand that you build to host on a website, on a web server, sorry. While a web application is a software that does not necessarily need to be hosted on any website, because it can actually run both on desktop and then online.
Okay, nice try. So let's look at what we have here. So actually, websites and web apps, a lot of people use them interchangeably, to the point that many cannot differentiate or many cannot tell whether there's a difference between the two anymore. Okay, so looking at here, at what we have here, websites are web pages that display information to users, allowing for little or no user interaction. Okay, while on the other hand, web apps are websites. Now note, web apps are websites that allow for many forms of user interaction. Okay, so websites are basically, they're just sites. They're websites basically that don't allow for users interaction. So when you say a website that only has, maybe you have an home page, it has only more of text content, probably images content, and all you have to do is just to read, move from home page and click a button to go to another page and read, more information. So you move from one page to another, all reading, but you are not required to, interact, so much with the website. Maybe interact by submitting your data, maybe form data, okay, or by clicking on a thing, or by entering text into a form input and click on the button to get a response back. Such is actually a website, okay? But any website that you visit that requires you to interact extensively, okay, with the website, then it is no longer just a website, it is a web app, okay? So another differentiation is website content are usually static and are only user facing or have only front end. They are not loaded from a database. Whereas web app content are loaded dynamically from a database and so require both front end and back end. So in the next section, we're going to be looking at the structure of a web application. So there we'll see the what's it called? What the front end means and the back end, and what the back end means. So we'll understand this point better. Okay. So website content are just static contents that are typed, okay, on the website, and they are uploaded on the server. Now, to correct what somebody said earlier, both a website and a web app are required to be uploaded on the web server. They are both required to be uploaded on the web server. Okay. So, but the only thing is that the content of a website are not required to be loaded from the backend, whereas a web app content are loaded dynamically. And most of the time, those contents are a response to the inputs of the user that is visiting the website. So let's say, for example, you go to Google, for example, you type in anything on Google. What is a website on Google? You click on enter, and you wait for Google to answer you or to bring in the result of your search based on what you have typed, okay? So the result is actually being loaded from somewhere. It's being loaded from a database, okay? So automatically that qualifies the website to be called a web app. Oh, sorry, my mic was muted. Are we together? Can you hear me? Hello, can you hear me? Hello? Can you all hear me? I need the feedback. I need feedback from someone.
I can hear you.
Oh, okay.
I can hear you.
Okay, so if you can hear me, I believe every other person can hear me as well. Okay, so the next thing is that websites are easier to design than web apps. Okay, they are easier to design than web apps, while web apps are more complex to develop. Okay, websites serve as a foundation to web apps, whereas web apps are built on top of websites. They are dynamic websites. So one thing you need to know is that web apps are actually websites, but they are websites with more functionalities, okay, with more advanced functionalities, okay. So HTML, CSS, and minimal JavaScript are required to develop websites. So shortly, we'll also be looking at the different programming languages, okay. Then web apps are more advanced. For web apps, more advanced tools and programming languages are required to develop web apps, okay. So the next thing we'll be looking at is the structure of web application. Can you all see the diagram on my slide? Can we all see this? Can we all see the diagram on my slide?
Yes, sir.
Yes, we can see.
Okay, so you can see there are two circles. Okay, there's one to my left and one to my right. Okay, so this is just a graphical summary of the structure of a web application. Okay, so web application has both the front end and the back end. Okay, so the front end is also called the client side. Okay, so this is the aspect of a web application where users, this is the aspect of a web application that users interact with. Usually, users submit data via a browser. Now, a browser in this case is called a client. Okay, that is where the user is interacting with the application from. Okay, so when you want to open or interact with a web application, remember what we said, you need a web browser. But for desktop applications, you don't need a browser. For mobile applications, you don't need a browser. For hybrid, you don't need a browser. But for web apps, you need a web app. And that web app is called the client. Okay, so the side of a web application where users interact with, where users actually interact with a web application is called the client. It's also or called the front end. Okay, so the client sends the user data to the server for processing, waits to receive a response from the server, and displays the response to the user or makes decisions based on the response. Okay, so that is actually how the front end of the web app works. Okay, user sends data, and an example of the data a user might send from a web app is maybe a registration form. You visit a web app or a website that has a registration form, okay, and you are required to register before you can actually log in and use the app. Okay, so a user fills in the form and clicks on the button submit. Okay, now the web browser loads and picks the data, the form data the user has just entered, and sends it, okay, to a place which we call the backend. Okay, then the backend processes the data and sends a response back to the user. Okay, so in the example of the form I was talking about, so after the user clicks on submit and the form is submitted to the backend, usually the backend can save the data into a database, okay, and send the response back to the user that your account has been successfully created, or even sends an email to the user, okay, that says your account, welcome to our website, this and that, these are your login details, So that is actually the basic workflow of a web application. Okay, so the other hand is called the backend server. This is the end. Hello, can you hear me? Can you hear me?
Yes, can you hear you?
Okay, and can you see my slide as well? Hello, can you see my slide?
No, not yet, sir.
Okay.
He's saying, no, not yet.
Okay, hold on. I'm trying to move to another internet. But I think it will be back. Please let me know once you can see.
Yes, sir. You're still saying no.
Okay, it's back, right? Okay, all right.
Web application structure.
Yeah, thank you. So this is the aspect of a web application that processes the data sent by the user from the browser. It consists of the web server, database, email server, cache server, amongst other server functionalities. Okay, so this is the other hand. Actually, when you visit a website and you start interacting, either by filling a form, and most of the interaction the user does on the website is actually mostly filling a form and submitting data through a form. You understand? So when you fill a form or you submit a form, where the data goes to is actually the backend. Okay, it is the server side. Okay, so that form is processed, or the form data is processed on the server side and sent back to the user, like I said earlier. So let's go back to the diagram I showed you. So the left part of this diagram is the user's computer or mobile phone. Okay, either the browser on the mobile phone or the browser on the computer. That's the client side. Then the right-hand side is actually the backend or the server side. So on this server side, you see different kinds of servers, okay, at the backend. You can see the database server, you can see the cache server, you can see the other kind of servers that work at the back to process the data that is sent, to process the data that is sent from the front end, and also processing the response that is sent back to the user. Okay, so this is the structure of web application. So every web application you see online, they actually have these two major structure, two major sides. Okay, so you are gradually being baptized into the world of web application development. So let's move forward to the next thing. So front end languages. Now, these are the client-side languages or the languages of the browser. These are the only languages that can be rendered by web browsers. Okay, and there are only three. So there are only three languages that can work or that can be interpreted by web browsers, and they are HTML, CSS, JavaScript. Okay, no other language in the world right now can be interpreted by a web browser or can be displayed by a web browser. These are the only three languages, and they are called front-end languages or languages of the web. So most of the time, when I see people or aspiring developers who are just starting their career, and most of the time, I hear them say, wow, I would like to learn Python, I would like to learn C++, learn Java, The first thing I ask them is, why do you want to learn Python? Why do you want to learn Java? Why are you interested in learning Java? Okay, and I find out that most of the time it's because they're just carried away by the hype. When you get online, there are some programming languages that are reigning right now. And one of the most popular programming languages right now is Python. Python, data science, Python. And because of that, most people think if you want to learn programming, Python is the programming language to learn. Okay? But that is not the best approach. That is actually not the best approach. Okay? So a lot of people just pick up a book on Python and start reading, and they will read and read for 1 year, 2 years, they just stop knowledge, they stop the syntax, and they are not able to actually do anything with what they have read because they don't understand some of these things. They don't understand what the front end means with its languages. They don't understand the back end with its languages. They don't even understand what the Python does. They just want to start because they are hearing the hype somewhere. But it is very, it's a great thing for you that you're attending this course, to actually know the differences between these things. Okay. By the time I'm done with this section, you will now understand the reason why it's not a good idea to begin your programming language, experience or training or learning from Python. So, or with Python rather. So let's move on. Let's move on to see the backend programming languages. Now, these are the server-side languages. Okay, they are languages that cannot be rendered by web browsers. They only function on the server environment. Some of the numerous examples of server-side languages are PHP, Java, JavaScript, C++, C#, Ruby, Python, and so many other languages that you have heard of apart from HTML, CSS, JavaScript. Okay, so it is safe to say that every other programming language, you have heard of outside of these three, outside of the HTML, CSS, JavaScript, they are all backend programming languages. They are all backend programming languages. So the Python that most people are talking about now, that is the hype everywhere now, is the backend programming language. Okay, it is in the same category as PHP. It is in the same category as Java. It is in the same category as C# and other programming languages. Okay, so now, why is it a bad idea to start learning coding from the backend? Okay, why it is always recommended to start from the front end. So at Zion Academy, we always highly recommend that you start your coding career at the front end. In fact, our syllabus, our curriculum is structured after this pattern. Okay, we'll take you through the first stage of learning of learning about these three programming languages, HTML, CSS, and JavaScript. Okay, before we now move you on to the advanced stage of now learning the backend, that's the server side, depending on whether you want to specialize in the backend or in the on the front end. Okay, now the reason why we advise that is because from our experience, those who have started learning coding from Python or any of the other backend programming languages, they get stuck. But the way the backend is, when you are typing the code, you don't get to see the actual result of what you are doing. Now, not that you don't get to see the result, but the backend, as we've seen, it's a back engine. It processes data that are sent from the front end. Okay, so the main job of the backend or of the server programming language or a backend programming language is to process the data that is sent from the front end, process it and either store it, okay, or manipulate the data and send a transformed version of the data back to the user at the front end. Okay, so the backend on itself does not really have a screen where you can see what is happening. Now, there are tools, there are tools you can actually use to debug, okay, or to see what you are doing, but it is often boring. So all you see is the coding environment, codes, those codes. It doesn't have the graphic side. Okay, so the graphic side of a web application is actually usually displayed at the front end. At the front end. So the front end is like the screen. Don't forget what we said. It is the side that the users interact with. If you visit a website now, the first thing you see on your browser, that is called the front end. Okay, so now we have those who specialize in developing the front end side. That is that aspect the users see. Okay, and they are called front end developers. Okay, most of you must have been hearing that a lot. I'm a front end developer. Some will say I'm a back end developer, while some will say I'm a full stack developer. Okay, so a front end developer is somebody who specializes in developing the aspect the users see. Okay, and to such people, that aspect is more fun. It's more fun because when you are anything you are doing as you're typing the code, you're actually seeing the effects of what you're typing on the browser. Okay, but at the back end, you have to rely on the front end for you to actually see the output. That is an interesting output. Not that you cannot see the output of what you are doing, but it is not as interesting. You cannot see the output on the browser. So oftentimes, backend developers rely on front-end developers to actually see the result of what they're doing at the back. So the reason why most people who have been or who started their coding career in Python have been stuck, and some of them have been discouraged and they've given up, is that they don't get to see what they are working on at the back. And before they can see, they need somebody else to help them develop the front end that they can now send the data to be displayed on the browser. Okay. Now, but because they have not learned how to develop that front end side by themselves by learning HTML, CSS, JavaScript, and they are starting straight from the back, they get frustrated. And most of them get stuck, and they're the ones that end up saying programming is hard, or programming is not interesting, or programming is boring. Of course, it will be boring because you started from the boring aspect. You understand? So that is why we usually advise that you start from the front, don't start from the back. Okay? At least have a basics of the front end, learn HTML, CSS, JavaScript, and learn to develop the client side that users will see. Okay, and only these three languages can be interpreted by the browser. So you start from here. Now, if you look at the programming languages there, HTML, CSS, JavaScript, and you compare it with the one at the back end, can somebody, I want to know if you are paying attention. Can you tell me a difference? Can you tell me, can you see anything a bit, what's it called now? Suspecting between the two. Can you say anything suspicious?
I see that JavaScript appears both on front end and back end.
Very good, very good. That's a very good observation. Now, sorry, this is 6:15, okay, and I'm going to have to ask, so that we can complete this training. I didn't want to rush it at all. You understand? That's why I'm still where I am now, I will have to ask for your permission to stretch it a little bit more, so that we can complete the whole syllabus. I would have said we should end it right here, okay, and come back tomorrow and make it 3 days. Actually, most times we make it 3 days. Actually, okay, we make it 3 days, but I was thinking we'll be able to crash it before into 2 days, but obviously, it's not. So do I have anybody's, do I have your permission to stretch a bit, maybe for another 30, 40 minutes, so we can complete the whole syllabus and wrap it up today? Please kindly unmute your mics and let me get your feedback on that. Hello, can somebody hear me? Hello, can somebody hear me?
I can hear you.
Okay, I need your feedback. Should we go ahead? Hello, I was talking about the timing. Should we go ahead? If I get...
Hello, sir. Can you hear me?
Yeah, I can hear you.
Yeah, I think I want to get it clear. So are you saying that because from the syllabus, I'm going to we finish, I think we still have some stuff to finish from the syllabus. So are you, if there is need for not to rush it or having an extra day tomorrow, I wouldn't mind, in my own opinion, rather than we just rushing it and they won't be able to cover the syllabus.
Okay.
That's my own opinion, sir.
Yeah, another person.
Yeah, I think if what is still left is going to span more than 1 hour, maybe we can push it till tomorrow.
Okay. So what is still left actually is not going to span up to 1 hour. It's not going to span up to 1 hour. Okay, and tomorrow might be a bit difficult actually for me. So, but it's not going to span up to 1 hour. But the place where I needed to waste time, so I can understand some of these things, we've already covered them. Okay, so the next thing now is networking. Once we are done with networking, then we're through. So I think we should just go ahead. It's not going to take up to 1 hour. Okay, so our Zoom, we all agree with that decision. So let's go ahead, please. So JavaScript can be seen as part of the front-end programming languages and also as part of the back-end programming languages. Okay, now what this means is that JavaScript is the only programming language in the world right now. It is the only programming language in the world right now that's sorry. Okay, I was reading a chat from someone. Okay, so that's the only programming language in the world right now that works both on the front end, at the front end and at the back end. Okay, and that goes to show you how powerful JavaScript is. It is very, very powerful. I mean, it works as a browser of the as a browser language. It also works as a server language. Okay, and that is one of the reasons why I believe so strongly, in my own opinion, JavaScript is eventually going to dominate all other programming languages in the near future. Okay, so JavaScript also makes it possible for you to easily become a front-end engineer and a back-end engineer. Why? Because the same JavaScript you write on the front end, that works on the front end, is the same JavaScript you write, on the server. It is the same. It's just a framework. There's a framework that makes it possible to run JavaScript code or JavaScript programming language on the server. Naturally, JavaScript before was not possible. I mean, it doesn't used to run on the server. It was not possible to run it on the server before. But recently, there were some things that were done, some new innovation, okay, called Node.js, okay, a new framework that made it possible, okay, for JavaScript to now be around as a backend programming language. So that has really actually shot up JavaScript, amongst the league of programming languages that exist in the world today. So it's one programming language I'll recommend for you to watch out for, and which is also one of the things we train on at Zara Technologies. Okay. but it's one of our main programming languages that we adopt. Okay, so during the course of your training, by the time we start the advanced class, we're going to be starting from the HTML, CSS, and JavaScript, and we'll be handing. Then once you have mastered this, then you will now specialize either in front-end development or back-end development. Okay, if you decide to specialize in back-end development, then you will learn any of these back-end programming languages. Okay, and use them to develop with the back-end side of the web application. Okay, after you have acquired the knowledge or the skill of developing a basic front end using any of these three, you will now go ahead to do an advanced course to master one of these, so that you can become what we call a full stack. However, there is another side, there's a deeper side to front end development. There's a deeper side, okay? There's an advanced JavaScript. If you want to specialize in front end, okay, you won't learn JavaScript at a basic level. You will go deeper than those who want to specialize whether in PHP or Java. Okay, you will go deeper if you want to specialize in front end to learn a framework like React.js, which is one of the most recommended frameworks for front end right now. You understand? So that is it about the programming language. So next time you see someone with this knowledge you have now who is saying, wow, Python is the best programming language, this and that, now you have enough understanding and enough information to advise the person, that it's better to always start from the front, okay? Then later move to the back, so that by the time you start working on the back end, you'll be able to also write the screen that will help you display the code you are running at the back, and you will enjoy the code much more better. So that is it about this particular session. So we're moving to the last section of the course now, which is computer networking. Earlier on, I briefly introduced computer networking to us, and that when we're looking at web applications, okay, we said web applications are run on a network. Okay, so now for you to be able to develop web applications, it's important for you to understand the network environment or what computer networking is. Okay, so that you can better troubleshoot later on and understand the ecosystem that where web applications run. So we're not going to be diving deep into that now. Computer networking. What is a computer network? So computer networking is the connection of two or more computers together for the purpose of sharing resources. Okay? So the definition is not complete if you don't add the purpose for which, why do you want to connect two computers together? Okay, the reason is because you want to share resources amongst, the computers, on the same network. Okay, so now we have different types of networks. Well, some people have dropped from this class. Okay, but let's continue. Now we have different types of networks. We have the local area network, and we have the wide area network. We have the local area network, and we have the wide area network. Now, the local area network is the connection of two or more computers within the same geographical location, while the wide area network is the connection of two or more computers across one or more geographical locations. Okay. Now, others are metropolitan area network and personal area network. Okay, so this image shows us an example of the local area. Hello, are we still together?
I think we lost you for a bit, but we can hear you now.
You can hear me, okay. So can you see my screen? I'm displaying the image of a local area network.
Yeah.
Okay. So let's say you have about 8 computers in a room, okay? So one of the benefits of network is that it enables users on the network share files easily. Okay, as we all know, let's say you have files on your computer and you are working in an office environment where there are about 5 or 6 or 7 people. Okay, and each of these other people depend on the file or on the document you are generating from your own computer. So without a network, if you want to transfer these files to these users, you need to copy it into a flash and give it to them physically. Okay, but one thing networking does, if you have a network or if all the computers in that space are connected together, you can easily transfer the file from your computer to their computer, or they can easily access the file and copy the file directly on your computer. Okay, so that's one of the benefits of network, whether a local area network or a wide area network. Okay, so one thing I just want to note is that whether we're talking about a local area network or a wide area network, they are all the same. Okay, the only thing that differentiates between the local area network and the wide area network is the size of the network, number one. And number two, the distance they cover. The distance they cover. Those are the two major differences between the two. Okay, so the same principle that applies on the local area network is the same, is also the same that applies to the wide area network. The only difference is the size and the number of computers and the number of servers you have to use. So now the next thing I want us to look at is the types of computers on the network. Now, this networking section is not going to be in-depth because networking in itself is very, very, very wide. Okay, it's very, very wide. It's a complete course on its own, but we are only going to extract the aspect of it that is important or that is crucial to web application development. So we're not going to be going too deep into them. Into the topic. So the types of computers on a network, computer networks, be it WAN or LAN, run on a client-server model. Okay, hence the computers on the network are identified as either server computers or client computers. So the first kind of computer you saw on the network is a server computer. So a server is a computer or system that provides resources, data, services, or programs to other computers known as clients over a network. It serves other computers on the network. If you look at a server is just like a servant. Okay, what do servants do? Looking at the definition of servants, a servant is a person who performs duties for others, especially a person employed in the house or domestic duties, okay, or as a personal assistant. But applying this definition to the client-server model, just to better understand what a server is a computer who performs duties or activities for other computers on the network. Okay, so that is what a server actually does. You understand? So while client computers are simply those operated by the end user of the client-server system of the internet, they connect to and use the resources of a remote computer or server. So every other computer on the network that is not a server are client computers. Okay, every other computer on the server that is not a client, on the network that is not a server are called client computers. Okay. So the next thing is, let's look at the advantages of computer networking. Now, the first advantage is hello, can you hear me and see my screen?
Yes.
Let me be sure I'm still sharing. Hold on. Hold on, please. Okay. So can you still see my screen and hear me?
Yes, sir.
Okay. So one major advantage of computer networking is file sharing. Okay, you can easily share data between different users or access it remotely if you keep it on other connected devices. Okay. Then the other thing is resource sharing. Using network connected peripheral devices like printers, scanners, and copiers, or sharing software between multiple users saves money. Now, apart from file sharing, one major thing which we want to emphasize for the purpose of our course is that softwares are one of the major resources you share on a computer, on a network. Apart from files, softwares. And the software I'm referring to is web applications. And don't forget, we said earlier that web applications run majorly on a browser. The applications that run on a browser. So those applications that run on a browser are actually, they are actually shared on the network. They run on a network as well. Don't forget, we also mentioned that they run on a network. You understand? So web applications that are installed within a network environment can be easily accessed by other computers on the network. Okay? They can be easily accessed by other computers on the network. And we said something that when we're looking at the disadvantages of desktop applications, we said one of the major disadvantages is that they are not easy to distribute. Meaning, if you have 1 million computers, you have to install a desktop application 1 million times on each of the computers. But in the case of a web application, if you have 1 million computers, that you want to install a web application on, all you need to do is make sure those 1 million computers are on the same network. Okay? Once they are on the same network, all you need to do is to install the web application on one of the computers, okay, which is the server computer. Now, don't forget, the major purpose of the server computer is actually to share files and to share resources. For example, if you want to share a printer now on the net with maybe like 5 computers on the network, you can simply connect the computer directly to the network, or you can simply connect the printer directly to the network, or connect it to a computer on the network. Then every other computer on the network will be able to access the printer, as long as it has been connected to one computer on the network. You understand? So the same principle applies. If you want all the people in an office or in an organization, for example, using a computer that are networked together, or using computers that are networked together, all you need to do is to install the web app on just one computer on the network, okay? And every other computer on that network will be able to easily access the web application on the network. You understand? So the next question is, how is that possible? How do other computers on the network, access, or how would they be able to access the web application on just one computer on the network? Even if there are 1 million, how would the 1 million computers be able to access, the web application on that single computer on the network? So that's the next thing I want to go into now. The internet. Want to try and demystify the internet and see how the internet works. Okay? So now, one thing I forgot to mention earlier when we are looking at the types of network is that the internet is an example of the wide area network. In fact, the internet is considered to be the largest wide area network. So the internet is an example of a network, like I said earlier, is an example of a network, is an example of a wide area network, okay? But it's considered to be the largest wide area network. So to know how the internet works, okay, if we simply look at how a local area network, how communication takes place within, or amongst computers on a local area network, it is the same principle that applies to computers on a wide area network. Because like I said, the major difference between a wide area network and a local area network is just the size, the number of computers on the network. That is the major difference. But be it a LAN, that is local area network, or a WAN, a wide area network, they are actually the same thing. I mean, it's the same principle that runs on them, okay? So, but before we look at how communication takes place on the internet, or what happens on the internet, let's take a look at what the internet is itself. So I have here, the internet is one of the largest wide area networks. It is the network, it is the network internet of networks. That is, it is the network of networks. You understand? So the internet is the coming together of different local area networks or different wide area networks to form a single network. That is what the internet is all about. Okay? So now, having looked at what the internet is, let me quickly go back and let's see what happens on a local area network. Now, the first thing you need to know about how the internet works is what we call the IP address. Okay? The IP address is a unique identifier assigned to every computer within a network, within a computer network. Without the IP address, it will be impossible for devices on the network to communicate with one another. And an example of the IP address is what you can see. It's usually written in this format, 192.168.0.1. Now, it could be any number. It could be any number between 0 and 255. So as you can see, this format is in 4 parts, and each of the parts are separated by a dot. So the first part cannot exceed, each of the parts cannot exceed 255. It's between 0 and 255, so it can be any number. So what this means is that there is no one computer on a network having the same IP address. There is no 2 computers on the network that can have the same IP address. An IP address are assigned to a computer on a network, only when the computer joins the network. Once the computer is not part of the network, it doesn't have an IP address. But the moment a computer is either connected to a network, either a wireless network or a cable network, automatically the operating system has been designed in such a way that that computer is assigned an IP address so that it can communicate within the network. Okay, so that is very, 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 very important. It's very important for you to. I will have demonstrated something for you, to show you that every computer on the network actually is assigned an IP address, but there's no way I'll be able to do it because I will have to disconnect briefly from the internet for me to show you. But if it were to be a physical class, I would have been able to show you that. But you can try this experiment yourself, on your own later. So when you open your computer now, for example, when you open in your computer, you open the command prompt. What I opened earlier when I was trying to explain the DOS environment, when I was explaining the DOS operating system, the command prompt, that black application on your computer, when you open it, if you type a command called ipconfig, okay? If you type a command called ipconfig, hold on, let me see if I can write a note here. Okay, no, it's not allowing me to write a note. So if you type a command called ipconfig, okay, inside the command prompt and you press enter, what that will do is that it's going to bring out the IP address of your computer. So the experiment is, if you try that command when your computer is connected to the internet, it's going to return a list of IP address, a single IP address, that has been assigned to your computer. Now, if you now disconnect from the internet and try that command again, ipconfig, you will see that your computer will no longer have an IP address. Okay, so that experiment will show you that it is only when your computer is connected to the internet that you get an IP address. You understand? So, so let's move on. Finally, let's look at how the internet works. So when you type in an address into your browser, okay, the first thing is that your PC or device is connected to the web through a modem or a router. Together, these devices allow you to connect to other networks around the globe. The router enables multiple computers to join the same network, while a modem connects your ISP, your internet service provider, which provides you with either cable or DSL internet. Now, the summary of what this is saying is that, we said the internet is the connection of different computers all over the world to form a single network. So which means a computer in Nigeria, in Lagos, Nigeria, can be easily connected to a computer in the US and can be easily connected to another computer in the UK. As a matter of fact, some people on this training are joining from the UK. About 2 or 3 people are joining from the UK. You understand? So we're in different parts and we can see each other.
I think we lost you for a bit.
Oh, okay. Okay.
Yeah.
So what's the last thing you had?
After you said the DSL internet, there was something you started.
Okay. Sorry about that. So I was trying to explain the summary of what that step 1 is saying. The summary is that, we said the internet is a connection of different computers in different parts of the world to form a single network. Okay. So what that means is that a computer can be here in Lagos and can be easily connected to a computer in Australia and can be connected to another computer in the US. As a matter of fact, some people on this training are connecting from the UK. So which means, as we are here, some of you, are in Lagos, some are in other states, some are in other nations, and yet we can all communicate to one another on a network. You understand? So that is what the internet, tends to achieve. Now, the way this connection happens is that, now this is the point where I should have asked that question I've been reserving, and that question is about the internet. Now, from experience from teaching this course, a lot of people, I found out that what a lot of people think of as the internet is not actually what the internet is. Okay, now there's no time to ask questions now, but let me just tell what I've realized. And so if you are in that shoe, you are expected to learn this today and know that the internet is not what you think it is. Okay, so a lot of people actually think internet means data. Okay, they actually substitute the internet to mean data. So that's when, if somebody no longer has data to connect or to browse the internet, usually hear, my internet has finished. Some people say, I don't have data or I don't have internet. Please send me money to connect to the internet, or to send me money to get the internet. Or internet connection has gone off. So my internet is bad. You understand? So that shows that a lot of people think the connection or the data is actually what the internet is. Okay? But that actually is not what the internet is. The internet is actually a network of networks. Okay, it's the connection of computers across geographical territories, across continents. It is an example of a wide area network. That is actually what the internet is. Okay, now what we're trying to look into now is how that connection takes place. How does a computer that is in Lagos connect? How is it able to connect to the computer in the US and they're able to communicate? Okay, that is exactly what we're trying to look at now. So before the internet can happen, okay, now you need connection. Now, if you look at the local area network, which I didn't mention, the way you connect different computers within a local area network is either through wireless connections or wired connections. So if it is wired connection, you use cables. There are different kinds of cables that you can use to connect two or more computers together. Okay, and you also use devices like switches and hubs, okay, to connect the different computers together. Okay, but if the distance of the two computers you want to connect, or the various computers you want to connect together are far apart, as in a wide area network, then you find out that you will be limited from using cabling. You will no longer be able to use cables to connect those computers in a far location together. So in that case, you make use of what we call wireless connection. Okay. Wow, so sorry about all this, disconnections. The internet is really, all the internet I've used are really, really poor. But I hope you can see my screen and hear me right now. Can you see and hear me?
Yeah, we can.
Okay, thank you. So, we're almost done. This is the last part. So, so I was talking
We can
about.
only hear you. We can't see the screen though. The screen is not the screen. We can only hear you.
Okay, it's going to come up a bit. Let me try to reconnect it. Okay, I think the reason why my internet is slow is because oh, I should have stopped it. I've been uploading yesterday's class, yesterday's training. I've been uploading to YouTube. That's actually what has been dragging the internet, and it has actually finished uploading now. Yesterday's class is available on YouTube, so we'll be sending the link to you later, so that you can refer to it. Then later on, we'll upload this one as well. So I think the internet should be much more better now. The upload was pulling the whole strength of the network. So can you see my slide now? Can I go ahead? Can you see my slide?
Yes.
Okay,
Yes.
Okay, thank you. So, so I was talking about how you connect computers in a wide area network. So because of the long distance, it's actually difficult to, sorry, I want to pull up this. Hold on, please. Okay. So because of the long distance, you can't actually use a cable to connect computers, over a long distance. So you use wireless communication. Okay. So, and one of the ways by which you can get access to wireless communication or to the signal you need to connect computers in a far distance is through internet service providers. Okay, internet service providers. So these internet service providers, they actually have access to what we call satellites. Now, one of the major means of actually transferring data between continents, okay, is through the satellite. Okay, we all know what the satellite is. Satellite is, a kind of wireless device that is launched into the space. Now, the reason why it is launched into the space is because when an object is in space, okay, it hovers over the globe. It hovers around the globe. Okay, so when you are in space, you see the Earth as a ball. You see it as a globe, right? So you can actually see multiple different continents at once, or you can see almost 2 or 3 continents at the same time from a particular angle in space. Okay, so what happened is that satellites are launched into space in order to be able to easily transmit signal from one continent to another continent. Okay, so now we have companies, okay, who actually interface with these satellite managers, or those who manage and maintain these satellites. Okay, so they have access to they own the devices, and they actually manage the signals that are being transmitted between continents. Okay, so these companies that interface with these internet managers, they could be a telecoms company, or they could be what we call internet service providers. And most of the time, telecom companies are also the ones who do the work, or who provide the service of internet service providers. You understand? So these telecom companies, what they do is that they interface and they sign a deal, okay, with companies that manage the satellites. They pay them a lot of money, millions of dollars, in order to be able to make use of their satellite to transmit data from one country to another country. Okay, so these telecom companies, who are most of the time also internet service providers, what they now do is that, so it's like they buy signal, or they buy access to the satellite in bulk, okay, from the satellite companies, and they sell it in retail to end users. Okay, so that is the reason why before you can connect to the internet most of the time, you need telecom companies, or there are some other companies who are not necessarily telecom companies, but they are also internet service providers. Okay, and some of these people actually, they are actually customers Okay, they buy from the telecom companies in wholesale. You understand? Okay, so companies like Globalcom, MTN, Airtel, these are actually the big companies who interact directly with the companies that manage the satellites. Okay, so most of them now resell to other ISPs like TZT, you know, and some other internet, you know, providers that we know. You understand? And some of them even offer the internet service, like we all know. MTN sells data. Okay, they sell data, they sell, you know, Glo sell data and everything. And what that data means is access. Okay, we are giving you access to a satellite we have access to also, you know, be able to transmit your data to other countries. So that is the reason why, without you buying a recharge card or buying data from MTN or Glo or any of the ISPs, there's no way you'll be able to transmit data from Lagos to another continent. Okay, so that is exactly what happens. So once they've given you data, you have to buy their SIM. Okay, you can call anyone within your territory or outside Nigeria. Because you have data, they've already sold the signal to you, the internet signal, they've sold it to you so that you can be able to connect to the internet. Okay, so once you send your data, the data goes to their own mast, it goes to their own network, and from their own network, they are able to connect to the satellite in space. Then the space is able to communicate or send the data to another person in Australia within a split second. Okay, so that is exactly what happens when you send a message from your WhatsApp in Nigeria to another person in the US, and the person gets it instantly. Okay, that is exactly what happens. It journeys from your phone to the internet service provider. From the internet service provider, they send it to the satellite, then the satellite sends it back to another ISP of the receiver. Then the ISP of the receiver now delivers it to the phone of the person at the other end. Okay, and all this happens within a split second. You understand? So that is exactly, you know, what happens behind the scene, you know, on the internet. Okay, so let me see, am I missing any other thing? Okay, so now I've tried to explain what happens generally on the internet, but now let us see what happens when you try to access a website via your web browser. Okay, so your PC or device is connected to the web through a modem or router. I've already explained this. Your router enables multiple computers to join the same network, while modem connects to your ISP, which provides you with either cable or internet. Now, step 2, when you type in a web address known as a URL, that is a uniform resource locator on your browser. Okay, each website has its own unique URL that signals to your ISP where you want to go. So your query is pushed to your ISP, which connects to several servers, which store and send data like a NAP server. Okay. Next, your browser looks up the IP address for the domain name you typed into for the domain. Okay, let me explain this. You know, this is becoming too, you know, it's becoming too like a textbook. But I want you to really get it. So let me try to explain everything that is written here. So what happens is that for you to communicate, for your computer to communicate on the internet, okay, let's see what happens on the local area network first. Let me go back to the picture of the local area network. Now, this is the local area network. Okay, so what happens is that, like I already mentioned, every computer on the network is assigned an IP address. The moment they are connected to this network, can you see my pen on the screen? So the moment they are connected to this network, each of these computers have been assigned an IP address. Hold on. Sorry, can you see me?